Dear students, welcome to the class of AE 307 Signals and Systems. This class deals with the topic classification of systems. First we deal with the concept of system. A system is defined as a physical device that generates a response or output signal for a given input signal. The output y of t is the transformed form of x of t that can be represented as y of t is equal to transformation of x of t, where x of t is the input or excitation and y of t is called the output or response of the system. The different types of systems are continuous time and discrete time systems, static and dynamic system, causal and non-causal system, linear and non-linear system, time invariant and time variant system, stable and unstable system, and the last one is the invertible and non-invertible system. The continuous time and discrete time systems. The continuous time system operates on continuous time input signal to produce continuous time output signal. Y of t is equal to transformation of x of t. The discrete time systems operates on a discrete time input signal and it produces a discrete time output. Y of n is equal to transformation of x of n. The continuous time system and discrete time system are shown in figure 1. The next type is that static and dynamic system. A system is static or memoryless if its output at any instant depends on the input at that instant but not on past or future values of input. The examples are y of t is equal to x square of t, y of n is equal to n into x of n. Otherwise, the system is said to be dynamic or with memory. The examples are y of t is equal to dx of t by dt, y of n is equal to x of n minus 1. The causal and non-causal system. A causal system is one for which the output at any time t depends on the present and past inputs but not future inputs. These systems are also known as non-anticipative systems. They are physically realizable systems. The example y of t is equal to x of t plus x of t minus 1. Y of n is equal to n into x of n plus x of n minus 3. The non-causal system is one whose output depends on future values. These systems are not physically realizable. The examples are given this is continuous time domain and this is discrete time domain. The next classification is that linear and non-linear system. A system that satisfies the superposition principle is said to be linear system. The superposition principle states that the response to a weighted sum of input signals be equal to the weighted sum of the outputs corresponding to each of the individual input signals. The superposition principle states that the response to a weighted sum of input signals be equal to the weighted sum of the outputs corresponding to each of the individual input signals. Here you can see that a system with an input x1 of t and its corresponding output y1 of t. This is x2 of t, a system with x2 of t and the output y2 of t is equal to transformation of x2 of t. The same system. The weighted sum of the inputs a x1 of t plus b x2 of t, if it is giving as an input to the same system, if it produces an output a y1 of t plus b y2 of t, we can say that the system is linear. We can simply write transformation of a x1 of t plus b x2 of t, which is equal to a into transformation of x1 of t plus b into transformation of x2 of t. This is applicable in discrete time systems also. The time invariant and time varying systems. The time invariant systems means a system is said to be time invariant or shift invariant if its input output characteristics do not change with time. That is, if a time shift in the input results in a corresponding time shift in the output. The time invariant system is shown in the figure. The time variant system means it not satisfying the above requirement. Such type of systems is called the time varying system or shift varying system. Stable and unstable system. A system is said to be stable, or we can simply say that a system is said to be bounded input, bounded output stable if and only if every bounded input produces a bounded output. A system is unstable even if one bounded input produces an unbounded output. The stable and unstable system. The stability from impulse response we can find like this. If the impulse response is absolutely integrable for a continuous time system or absolutely summable for a discrete time system, we can say that the system is stable. Integral minus infinity to infinity modulus of h of t dt less than infinity, where h of t is the impulse response of the system. In discrete time systems, summation n from infinity to infinity, minus infinity to infinity, this is actually minus infinity, summation n from minus infinity to infinity, modulus of h of n should be less than infinity. The invertible and non-invertible system. If a system has a unique relationship between its input x of t or x of n and output y of t or y of n, then the system is known as invertible system. For an invertible system, if y of t or y of n is known, x of t or x of n can be founded unambiguously and uniquely. Such type of systems are called as invertible systems. The figure 3 represents the invertible system. These are the different types of system. Thank you.